In this section on fractions, we're going to talk about adding fractions. We're going to be adding proper fractions here, and we're only going to be talking about adding fractions that have common denominators. In future segments, we'll use ones that have different denominators as well. As we mentioned earlier in previous segments, it's important that students understand that when we're adding things, the things have to be the same. I can't add things that are different. So in this case, we're going to be talking about things that have the same shape, things that have the same denominator, or the same size. So all of those things are going to be the sameness that's going to allow us to add. I'll be using the new fraction blocks that show 1 as 2 pink hexagons together, and I'll also be introducing the array model that allows us to show pictorially some of the things that we're doing symbolically and concretely with the manipulatives. So here's our question, 1/4 plus 1/4. Our instructions could be something like add, or it could say simplify, or it could say collect like terms. All of these would mean the same thing, depending on what grade you're teaching. So if we're using these manipulatives, this is the fraction block that indicates 1 whole, and if we need 1/4 of that, we need our 1 whole divided into 4 segments, and those 4 segments would have to have this shape. And so if they're asking 1/4 plus 1/4, this is what we end up having. And what size is that going to be? What's my answer going to be? Well, if I have 1 red plus another red, I now have 2 reds. So instead of calling them 2 reds, each red is called a quarter. So if I have 1/4 plus another quarter, I'm now going to have 2 quarters. Now some students are going to notice that 2 quarters is recognizable as a half. So how does that work with our pictures? If I rearrange them in this direction now I have 1 of the hexagons out of my possible 2, so now I have 1 out of 2, which we called 1/2. And I can show that by covering that up with the hexagon, so now I have 1 out of the 2, which is again 1/2. So I want to take a second now to show symbolically how this might work. Concretely it makes perfect sense. Symbolically, what do we need to show the students? Lots of students, when they take a look at this question without the blocks, they see 1/4 plus 1/4 and they get the answer of 2/8. Makes sense, 1 plus 1 is 2 and 4 plus 4 is 8, but it doesn't really make sense when you're talking about what it is that we're adding. We're adding quarters. I've got 1 of them, and 1 of them should give me 2 of the same things, and they're 2 quarters. How do we change that to our half? Now we talk about using our magic 1 before. And we're going to divide by our magic 1, and we know that dividing by a magic 1 doesn't change anything. And how do we know that we're going to use the 2/2 version? Well, we know a couple of ways. That we know that the top and the bottom number both divide by 2, so I can use that as a magic 1. But I also know that I'm trying to make this shape. And to make this shape, it takes 2 of these things to make that shape. And because it takes 2 of them, that's why I'm going to use this version of my magic 1. So 2 divided by 2 is going to give me 1, and 4 divided by 2 is going to give me 1/2. And so symbolically, this might be the work that we show. 1/4 plus 1/4 gives me 2 quarters. I can reduce 2 quarters by using my magic 1 down to 1/2, and now I've reduced it to its lowest terms, and it still indicates that 1 out of the 2 pieces that make up my whole are covered. So 2 quarters is equivalent to 1/2. Now I'm going to show the other technique. So in this technique, I want to produce a square of side lengths 1, and I want to leave them as 1s because I'm talking about proper fractions. So since they both have common denominators, I don't have to do both sides, but I will show you how to do it with both sides in a minute. But since they're both quarters, I don't need to do both sides. I've got side length 1, and this one I've cut into 4 pieces. So I should be able to make a square of length 1. And there it is there approximately. And since it's 1/4, I've created a rectangle that's 1/4 of this square. So there's 1/4, 2 quarters, 3 quarters, 4 quarters. So I'm just going to slide this 1/4 in. So I've shaded in 1/4. And now to that I'm supposed to add another 1/4. So I've made another 1/4. So together now I've got 1/4 plus 1/4 will give me 2 shaded regions out of my 1, 2, 3, 4 regions that are possible. So my answer is 2 quarters. But then we talked about that it can be reduced to 1/2. We can see that this is the 2 yellows cover over 1/2 of my square. And just to prove it, I can show that visually. And so I've shaded in the other region, and I can see that If I do this, that covers my 2, and I do that, that covers the other piece. So therefore I can see again that that's 1/2. So I can show that 2/4 is equal to 1/2, and there's my reduced version of it. Symbolically, there's my reducing that I've shown with my magic 1, and pictorially here it is. 1/4 plus 1/4 is 2/4, and 2/4 is equal to 1/2. Now I'm going to show you how I can do it in another version of this same pictorial diagram. So in this diagram I have my same square. It's still 1 by 1, and I've divided this one up into 4 pieces across the top, but this time I've divided it into 4 pieces down the side. So my first 1/4 is here in the yellow, and my second 1/4 is going to go across the side, so I'm going to make a 1/4 horizontally. And so I've shown my 1/4 here. There it is, that's 4 pieces. So horizontally that's 1 out of my 4 pieces, and I'm going to slide it on top. So now I've got 1/4 in the yellow plus 1/4 in the blue, and I want to add those segments together. So the way this technique works is I'm doing an adding question, so I want to add up all the single colored segments. So here's one segment here, here's another segment here, here's another segment here, here's another segment here, here's another one here, and here's another one here. So I have 1, 2, 3, 4, 5, 6 colored segments. But what's happening up here in the corner is a little different, so we want to talk about that separately. So when I take and I just move this one out of the way, I notice that this segment up here is colored in the yellow. So I want to give it a tick mark because it's colored in yellow. But I also notice that when I bring this segment back up here, it's also covered in blue. So I need to give it another tick mark because it's one of the blue covered segments, and so we want to give that a tick mark. So how many tick marks do we have altogether, or how many single colored sections? We have 1, 2, 3, 4, 5, 6 singled plus this double, so now I get 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 colored in segments. So I've got 8 colored in segments out of how many? Well, if I have a 4 by 4 grid, I've created a square that has 16 segments. So I should be able to say 8 out of 16. Students might say, well, 8 out of 16 I know is 1/2, so symbolically we want to show how do we prove that. So I'm going to divide by some kind of magic 1. Now which magic 1 do we want to choose? Well, some students would notice, well, I've got 4 on both sides. So if I use 4 on both sides, 4 must go into both 8 and 16. So I'm going to use my magic 1 known as 4 over 4. And that's going to produce a reduced fraction known as 2 over 4, but I can reduce that some more. So I divide it by my magic 1 again, and I can get to 1/2. Some students would say, well, I can divide it by a bigger. I've got 4 on both sides. Can I divide it by 8s? And the answer is yes. And now I can see that if I use my magic 1 that's with larger numbers, I can get down to my reduced fraction faster. 8 divided by 8 is 1, 16 divided by 8 is 2, and I get my answer of 1/2 again. So I've shown that 1/4 plus 1/4 equals 2/4, which reduces to 1/2, both with the concrete manipulatives, and 2 ways with my pictorial, one with my 2 columns, and I didn't have to do them with horizontals because they both had common denominators, and I also showed you how to do it with 2 different ones, one going vertically and one going horizontally, one for each of the 2 fractions. And either way, I get my answer of 1/2. In all 3 techniques, I can show that 1/4 plus 1/4 equals 1/2.